All right, section 11.3 is multiplying rational expressions. And you remember when you're multiplying two fractions together, all you have to do is multiply the numerators and then multiply the denominators and then of course reduce your fraction. So here we go. We've got two fractions here, rational expressions. So the first thing, let's see, I think, there we go. So you did this in the previous section. The first thing is you're going to reduce the fractions, right? So we're reducing the fractions. And you do that by factoring the numerator and the denominator and then canceling common factors. So let's look at them. So this first one does not factor at all. This one here is a trinomial, so it factors to be x plus 2x minus 2. This right here doesn't factor, and then this one factors to be the x plus 2 and the x plus 1. And now that you've factored everything and you've checked your factors, remember you want to check that middle term, make sure you factored correctly. All right, so you still have to do that mental check. You can then, now you're going to then cancel, right, common factors. So let's cancel common factors. We have the x plus 3 and the x plus 3 cancel, correct? What else do we have that will cancel? We have x plus 2, x plus 2. That leaves us then, now we can, once we factor everything, we can do step 2 here, just multiply the fractions, right? So we're just going to multiply straight across. Remember, this became 1, right? This became 1. So this 1 times x plus 5, minus 5 is x minus 5, and this times 1 is the x plus 1, right? So that's how they came up with these 1s, and then we multiply them straight across. All right? Once you have done that, you've reduced the fractions, you've multiplied, then you still have to determine the excluded values. That's what you did in the first section of this chapter. Right? So let's look at what we canceled in the denominators. All right, so we canceled an x plus 2 in the denominator and we canceled an x plus 3. So we're going to take both of those, set them equal to 0, solve for x, and then we're going to write therefore x cannot be a -1 or a -3. So you have to do that step 4 where you notate it. So you have your answer. So this here's your answer, where x cannot be 1 or x cannot be a -3. You could also write this as x cannot be -1, -3. Either way is acceptable. Pretty straightforward. It's the same thing you did in section 1 and 2. The only thing that's new here is that now you're multiplying, and so you're going to be multiplying when you get to the very end. You're just going to be multiplying your numerators and your denominators. So here are two. Let's look at the first one. All right. So the first one, and if you want, you can stop your video and try this one on your own if you'd like. So let's look at the first problem. I'm going to make this 6 here into 3 times 2. All right, so everything's in factored or prime numbers. Then I'm going to cancel common factors. So my 3's factor out. All right, there is no y that factors out. So now that you've factored everything, you're ready to multiply straight across. And so you end up with 5x times 2x is 10x squared, and 1 times y is y. You still have to do that step 3 normally. You would have to do the step 3, right? Which is what? Determine the excluded values. Well, the only thing that we canceled in the denominator was the 3, and there's no variable there. So this is one of those cases where there are no values to exclude, right? So no values are excluded. So that's one of those special cases. Let's look at the next one. Same thing. We're going to first what? We're going to reduce the fraction by factoring and canceling common factors. So let's look at it. Notice that I made this 4 to be 2 times 2. I left everything the same. There's no reason to write a times a times a out. All right. But now we're going to cancel the common factors. So I can cancel the two C's. There's a C on the bottom and the C on the top. There's also a 2, right? A 2 on the top and the 2 on the bottom. Notice that there's an A. So if I factor out this A on the bottom, I'm taking one A out. But on the top, there's 3 A's. That's what this exponent means, that there's 3 A's there. So when you factor one of the A's, then you're left with A squared. And the same idea with the B. So if I cancel out this B on top, then I'm left with 1B on here. Now we can multiply straight across. The only thing we're left with, this became 1, right? So now we got everything. We're going to multiply straight across. 2A squared times 1 is 2A squared, and 3 times B is 3B. Now we need to do step 3. Well, let's look at what did we cancel here? Well, we canceled out this variable C, we canceled out a variable A, and we canceled out a variable B. So notice I've written C, A, and B, and I've set them all equal to 0. So from there, you would think, oh, well, then C cannot be 0, or A cannot be, so, C cannot be 0, A cannot be 0. But in the B, we don't need to do the B because the B value is not part of an excluded value since there is a factor B remaining. Notice that we still have a B in the denominator. So since there's a B that remains in the denominator, this is not a value that we have to be concerned with excluding. So in your final answer then, you would write where A cannot equal 0 and C cannot equal 0. Let's look at another example. I want you to try this one. Stop the video and try it. Come back. All right, so we're going to factor. We're going to factor the numerators and the denominators. Here we had a GCF of 3. So I factored that 3 out. This is a difference of squares. So it factors nicely to be x minus 1, x plus 1. All right. And then, of course, we have the 3 on the bottom on the second fraction. And then let's look at this trinomial. We factor it, and it is factored to be x plus 1, x plus 1. So we have factored everything. Now, after we have factored everything in the numerator and the denominator, we want to cancel the common factors. So let's do that. The 3's cancel. There's an x plus 1 and x plus 1 on the top and the bottom that cancel. All right, and then now we can just bring everything down that was left. Remember, this becomes 1, not 0. So that's how we got the 1 there. And now we can multiply straight across. But instead of multiplying straight across, we're going to go ahead and leave them in factored form. So you wouldn't take this and go x times x is x squared, x times 1 is a negative 1, negative 2. You wouldn't go ahead and put it back into a trinomial. Go ahead and just leave it all in factored form. All right? Now we need to do step 3, right? Notice what did we cancel? We canceled out this x plus 1, so that's why we have to set it to 0. We canceled out a 3, but there's no variable there, so we're okay. So in step 3, then we're going to go ahead and solve. But why would I say, why wouldn't I just say x equals a negative 1, saying x cannot be a negative 1? Why wouldn't I have done that and made it an excluded value? Remember what happened in the last problem that we just did? The last problem we just did, we looked and said, okay, we're looking at this x plus 1. Well, there is an x plus 1 that remained in the denominator. Therefore, it's not part of the excluded values. All right, so we don't have to put where something does not equal something. This would just be your final answer in this particular case. And try this one. And now hopefully you've had time to do that. We're going to go ahead and factor the trinomial on top. And there's a GCF here of 6 on top of the second fraction. There's a GCF of 2 on the bottom of the second fraction. But now let's look right here. This one, before you factor this, remember, what's the first thing you always ask yourself? Is there a GCF? There was. There's a GCF of 3. So make sure you factor out that 3 before you factor this. So I saved it for the next turn. So this x plus 6x minus 8 became x plus 2 times x plus 4. Now we factored everything. Now we can go ahead and cancel out common factors. So we have an x plus 2, x plus 2. We have the x plus 4, x plus 4. And then notice here, you could write this as 2 times 3, the 6. So factor that out. And so sometimes you may want to do that. But since we're dealing with simple numbers here, you just know that, well, what is 6 divided by 2? 6 divided by 2 is 3, right? Well, what happened? What were they doing? They were actually canceling out the 2, and that 6 becomes a 3. But there is one more. Hopefully you see this. You can see that there's one more factor that can be factored out, and that is the remaining 3's. There's a 3 over here, and then there's 3 that you had created here. Go ahead and ask what remains. Go ahead and multiply then straight across. And, oops, something didn't show up on my slide. Let me go back here. Okay, so now this is what remains. Now look at this. This is x minus 3 on top and 3 minus x. They're not the same at all. But what if I rewrote this to be negative x plus 3? All right. Are they the same? Can they cancel out? No. One's a positive x, one's a negative x. One's a negative 3, one's a positive 3. But what I can do then is I could take this, I can factor out a negative 1, and I end up with x minus 3. So this now becomes x minus 3. What happens then is now I can cancel out this x minus 3, and now I'm ready to multiply. So I end up with 1 times 1 is 1, and 1 times a negative 1 is a negative 1. So now hopefully you understood how I got that. This became a negative x plus 3, but then we changed that to be a negative 1 times x minus 3, right? And then we canceled it out. So I went ahead and wrote that over there because I'm going to have something pop up here. Multiplying straight across, we get 1 divided by negative 1, and 1 divided by negative 1 is the same thing as a negative 1. But we haven't done our step 3. We have not done determining that values. Well, let's look at what we canceled out here. Okay, we canceled out the x plus 2. We canceled out an x plus 4. And here in the end, what did we cancel out? We canceled out an x minus 3. So we're going to set each one of those to 0. We're going to solve then for x, and then we're going to write our excluded values. So the answer here is negative 1, where x cannot be a negative 4, a negative 2, or a 3.